Good news, I remember today's lecture.
Yeah, 100%. He's like, I got one, I had wrong, but it don't have
Hi, good morning, everybody. Hopefully you're ready for another exciting morning of chemistry with your host, me, Dr. White. Hi, important announcement. Everyone, important announcement. This lab Friday, you do not have to do a to-do list. You notice it says handout from instructor. I'll give that to you in lab. On Friday, you have to wear proper clothing, but you don't have to bring your safety goggles because we won't be using any chemicals. But we'll still be in a chemistry lab, so you need to wear proper shoes, etc., no shorts and so on. But other than that, also, please work on the problem sets for ionic and covalent bonds, the last two chapters. I'm going to go through that on Friday, the lab Friday. I think we'll all be out of here by 10:15, 10:30 at the latest. But if you need me to stay around longer, I will. I don't have a plane or train or bus to catch. Or an appointment. Well,
something does look like a weapons way. I don't know. Somebody, it's not flash.
sorry about the delay. I was thinking of chapters of the other school I teach at, which are not the same chapters here, obviously. All right, I was talking yesterday, Monday, about chemical reactions. And I was talking and finished up balancing chemical equations, but let's back up one step, which I just did, and let me remind you, chemical equation. At the base of the arrow are the reactants. At the head of the arrow are the product or products. And also,
Did you get this? There you go.
if you look at this, the reactants, because I worked in industry for many years, we'll call it the starting materials. And I'll be subtle again today, you should know this. And when we talk about a chemical reaction, like A plus B makes C, there's an important concept which I started talking about on Monday, and that's conservation of matter. Thank you.
Oh, you're welcome.
And conservation of matter is the fact that in a chemical reaction, you never destroy or create atoms. What you start with, the same type and the same number of atoms, is what you should end up. They're just arranged differently. So if we look at the following chemical reaction, which I talked about, but I'll do it again now. Is it balanced? And the answer is no. How do you know? Well, simple. I have 2 oxygens here and 1 here. Well, you have to balance it. And this is a skill chemists need to know, and you need to know. Well, you don't need to, but if you want to lose anywhere from 9 to 12 points on the next test, and also the final, you need to know. All right, how do you do that? Common mistakes students make are they change the chemical formula. You can't. This hydrogen always exists as H2. Oxygen always exists as O2. Water exists as H2O. What you can change is the number in front. We call this the coefficient. If you see no number, it's 1. So if I have 2 oxygens on this side, how do I get 2 here? I change the number in front to 2. But now, how many hydrogens on this side? 2 times 2 is 4. Oops, we don't have 4 on this side. We only have 2. How do you get 4? You change the coefficient, the number in front. And if I do this, I have 2 times 2 is 4. And now I'll check, just like when you're balancing a checkbook. On this side, I have 2 oxygen. This side, I have 2 oxygen. On this side, I have 4 hydrogen. And this side, I have 4 hydrogen. Success. Conservation of matter is upheld. And now we have what's called a balanced chemical equation, or reaction. And what it tells us is you need 2 molecules of hydrogen to react with 1 molecule of oxygen to make 2 molecules of water. And now it's balanced. Like I said, I brought my lecture today. And let's look at this reaction. And the question is it balanced? And the answer is, I don't know, I'll have to find out. I have one sodium here, one sodium there. That's looking good. I have 2 chlorine here. Oops. I only have 1 chlorine there. Now, by now you know Dr. White shares the fun, so why don't you try balancing this? You can only change the numbers in front. Remember when you're done, look up and smile. Oh, it works. Really works. All right, I think everybody's done because I see a lot of smiles out in the crowd. Oh, I was just going to do a generation gap. How many of you have ever heard of the show, TV show? It's very popular, even though I didn't like it when I was a kid. Howdy Doody. One. Go on the internet and find it. And anyways, and they'd always say, all right, so they had a live audience of children, and they called that the peanut gallery. Why, I don't know, but I was going to say, is everybody happy in the peanut gallery? Never mind. All right, is this balanced? No. How do we balance it? Well, 1 sodium, 2 chlorine. How do I get 2 chlorine? I do that. Now I have 2 chlorine, but now I have 2 sodium. I only have 1 sodium. How do I balance this? Put a 2 in front, and now I have 2 sodium. And because I'm Dr. White and I like to double check everything, did I do this correctly? 2 sodium, 2 sodium, 2 chlorine, 2 chlorine, it's balanced. And now you know 2 sodium atoms react with 1 chlorine molecule to make 2 sodium chloride molecules, otherwise known as, please pass the name. And there you go. All right, now, these are simple ones. Let's look one a little more complex. By the way, C3H8 is propane. That's the stuff in the white tank for your barbecue. And this is called combustion. I'll talk about it later. And when you react propane with oxygen, you get carbon dioxide, water. What I don't show down here, because it's not a chemical to balance, is you also get heat, which is how you cook your food on your barbecue. Now the question is it balanced? And the answer is no. How do I know? Simply 3 carbons, 1 carbon. Now, everybody, can I have your attention? This is an important tip or trick from Dr. White that's never failed me in all the years I've been balancing equations, and I've been doing it a few more months than you have, a few more months, and that is, listen carefully. When you're balancing equations, leave oxygen and hydrogen last. Do those last. You can try them first, but it makes your life infinitely harder. And for me, I like my life infinitely simpler and more pleasant. So leave oxygen and hydrogen for last. So if I look at here, well, I've got carbon. How many carbon on this side? 3. How many carbon on this side? 1. How do I get it to 3? Change the coefficient, the number in front. And now all I have left is hydrogen and oxygen, so I'm going this way. I'm going to be lazy. I'll pick hydrogen first. You could have done oxygen, it doesn't matter. But at this point, I will say, how many hydrogens? 8. How many over here? 2. How do I get that to 8? Because you have to have the same on each side to balance it. I'll put a 4 in front. And now I have 3 carbon, 4 times 2, 8 hydrogen. And what's left? Oxygen. I have 2 here. Now, here's an important point. You look at all the atoms, or the type of atom on one side, not just in one molecule on one side. So if I look here, how many oxygens do I have on this side? Well, in carbon dioxide, I have 6 oxygen. In water, I have 4 oxygens, 4 times 1. I add it up, I have 10 oxygen. Now I'll put a quote so you know that's a 0, O, not a 0. Well, if I have 2 here, how do I get it to 10? Oh, I know how. 5 times 2. So now I have 10 oxygen on this side, and let's check and see if it's balanced. 3 carbons, 3 carbons. That's looking good. 8 hydrogens, 8 hydrogens. Wow, it's really looking good. Now, home stretch. 10 oxygen, did I say hydrogen, 8 and 8 hydrogen? 10 oxygen, 10 oxygen, are balanced. And what this tells us is, when you make your steak, hot dogs, your hamburgers, and your barbecue, if you're a vegetarian, when you grill vegetables and tofu, I don't know, do you grill tofu? I've never done that. Anyways, you take 1 molecule of propane, react it with 5 molecules of oxygen to get 3 molecules of carbon dioxide and 4 molecules of water, plus you get a lot of heat, which is what cooks your food. And this is how you balance it. The key is leave hydrogen and oxygen last. And as you know, Dr. White's going to share. I don't want to have all the fun up here. C7H16 is heptane. It's a component of gasoline. And when you burn it with oxygen, like in your car engine, you get carbon dioxide, water, plus heat. The heat is what helps expand the gas in the cylinders of your car to make it move. And I would ask you to have some fun and balance it. Remember, my advice, I call it a trick, but call it advice, is leave hydrogens, oxygens last. And while you're doing that, I'm going to get a refill. Or as Arnold would say, I'll be back. I kept my promise, I came back. All right, anybody need more time? Going what? I see people are still checking. All right, let's do this. All right, the question is this balanced? And the answer is no. Now, I have 7 carbons here, 1 there, so I know it's not balanced. So what do? I leave hydrogen and oxygen last. Now come over here and say if I have 7 carbons here, I better put a 7 in front to have 7 carbons here. Well, that's balanced now. I'm going this direction. I can do either hydrogen or oxygen. I'll do hydrogen because it's right in front of my face and I'm lazy. Organic chemists are like that. I have 16 hydrogen. Oh, I only have 2. How do I get to 16? I'll put an 8 in there. And 8 times 2 is 16 hydrogen. And now, am I done yet? No, I still have oxygen. I have 2 on this side. How many on this side? I have 7 times 2 is 14 plus 8. And if we do the math, that's 22 oxygen. And how do I get 22 on this side? Well, I have 2 here, 2 into 22 is 11, and therefore 11 times 2 is 22 oxygen. And now I'll check to see if I'm balanced or not. 7 carbon, 16 hydrogen, 22 oxygen, 22 oxygen. Dr. White's happy. Oh, that's so bad, I'll never do that again. Well, maybe not, I see smiles in the crowd, but you can see I'm never going to be an artist. But that's how you balance it. Oh, let's have fun with the good one. And let's look at this chemical reaction first. And the question is it balanced? You can tell quickly the answer is no. 1 iron here, 2 there. Why don't you try balancing this? Remember my advice, leave hydrogen and oxygen last. Have fun. While you're doing that, I want to look up something real quick.
There's 2. Oh, okay, sorry. That's 12, so that. Well, that's not what it is. So it's 3 of that's 12.
Remember, keep your eyes on your own paper. I'm just practicing for the test.
You can't cut them on like that. So it's we're separated by the pluses and minuses. So that's control and take 1. Take 3 right there. So change that. 3 plus that.
Remember, if you're having a little trouble, you're just starting out, this year new, you're still all rookies. You're one of you, so
Oh, and then that would also make it 12, right?
Yeah.
So, okay,
So, yeah.
so now check out. Because this would still be 3 as, and it'd still be 12. That's hard.
All right, anybody need more time? All right, looks like a couple of you are having a little difficulty. Everybody watch me, I'm going to do it now. And the question isn't balanced, the answer is no. Remember my advice to you, do hydrogen, oxygen last. So I'm going to start with iron. I have 1 here, I have 2 here. So what do? I'll put a 2 there. That wasn't that hard. Next, hydrogen. Dr. White says leave that to last, so I'm going to follow my own advice. And sulfur. I have 1 here, but 1 times 3, I have 3 sulfur. And now, how do I get 3 sulfur? I can't change the formula, but I can change the number in front called the coefficient, and I can put a 3 there. So now I have 2 iron, 3 sulfur. Looking good. Now all that's left is hydrogen and oxygen, so Dr. White's now going to do them. How many hydrogen on this side? 3 times 2, 6 hydrogen. How many on this side? 2. How do I get the 3? To 6, I mean, I'll put a 3 in front. 3 times 2, 6 hydrogen. And what's left? Oxygen. How many on this side? 3 times 4, 12 oxygen. And how many on this side? 3 times 4, 12 oxygen. And now before I leave this, I'm going to check, did I do it right? And how do you check it? Are both sides the same? 2 iron, 2 iron, 3 sulfur, 3 sulfur, 6 hydrogen, 6 hydrogen, 12 oxygen, 12 oxygen, success. And that's how you balance an equation, something like this. Again, it's never failed me. Leave hydrogen and oxygen last. Now you could start earlier, and you can do it that way, but how should I say this? It's more time consuming. And it's, how should I say, not as pleasant, or sometimes I can say it can be more frustrating. Always leave hydrogen and oxygen last, and it makes your life easier. Right. There's another thing I want to show you. I call this even odd. And if you look at this equation, is it balanced? The answer is no. I have 1 chlorine here and 3 there. And if I say, all right, I'll put a 3 in front of here, I would have 3 hydrogens. But over here, I only have 2 in here. What whole number can I multiply 2 by to get 3? And the answer is there is none. Remember, you can't change the number, and also coefficients are exact numbers, which means they're whole numbers. They're always whole numbers. You can't have 2.5 molecules of water reacting, just like you can't go out and find in the hallway half a person who's alive. Show me and I'll be surprised. No, you can't. And therefore the coefficients always have to be whole numbers. Now if you notice, here I have an odd number, and here I have an even, or better yet, I want to get this is odd, this is even. And they're both in the same molecule, so how do you correct this? Well, what's the number these two things go into? And the answer is you multiply it. And 2 times 3 is what? 6. So if I were to put 6 in front of here, I now have 6 chlorine. How do I get 6 chlorine here? Put a 2 there. I now have 6 hydrogens. How do I get 6 hydrogens? Put a 3 there. And now I look at zinc. I need 2 of them, so I have 2 zinc. I have 2 zinc. I have 6 chlorine. I have 6 chlorine. I have 6 hydrogen. And I have 6 hydrogen. And this is called even odd. And I was looking at my lecture notes here. I don't think I have another example. On Friday, I'll bring one to lab so you can do one. But the key thing is, find 2 on each side. You have one that's an even number and the other is an odd. You can never get them to be multiplied. If you said 3 and 2, you can never convert 3 into 2 or 2 into 3. But if you multiply them by each other, and that number each go into. And I call this even odd. one more. It's not even odd, but it's a little more practice. Usually on test 2, I will include anywhere from 3 to 4 of these 3 points each. And the question is balance the following chemical equation. Now, before I put this next chemical equation, please note, I teach by my golden rule of teaching. Did I ever tell you that? And that is, I don't do to my students what I didn't like done to me when I was a student, which I was a long time ago in a galaxy far, far away, but I was. And I hated on a test, I had a teacher who put balance the following, and one of the correct answers was, it's already balanced. Well, if you ask me to balance an equation, why is it already balanced? So I'll never ask you to balance an equation and give you a balanced equation. You'll always have to balance it. Trust me, I always will do that. Have fun. Balance the following chemical equation. And here I have the steps I've been talking about. Balance it, check and see if it's balanced at the end. And we're doing practice time. I tell you, years ago, I used to make students go to the board. I was in a classroom when we used to be in BIC that had boards on the side and the front, and I put these up, and I'd make students, did I tell you that? And I used to make them go to the board, and I said, come on, go to the board. Until I realized they'd rather pull their teeth out with pliers than go to the board, and I said, why am I making my students miserable? I stopped doing that. I mean, literally, they would rather about yank out than go to a board. I think everybody's done or lost. No, I shouldn't say that. Let's do it. Is it balanced? Well, I have one lead here, one there. I have 2 nitrogen here, and it's not balanced. So I'm going to follow my advice and say I have 2 nitrogen here. And how do I get 2 nitrogen here? Put a 2 in there. 2 nitrogen. Next, I have 1 lead there, 1 lead there. I'm going to do oxygen last. I have 1 sodium here and 2 sodium there. So I can correct that. I have 2 sodium. Now, once you do this on one side or the other where you put a number in there, try not to change that or it makes your life difficult. So since I'm not going to change this, I have 2 chlorine here. Oh, look, I have 2 chlorine there. And then what do I have left? Oxygen. 3 times 2 is 6 oxygen. 2 times 3 is 6 oxygen. Don't forget 1 lead and 1 lead. And now I'll check, is it balanced? Well, let's find out. 2 nitrogen. 2 nitrogen. 6 oxygen. 6 oxygen. 1 lead. 1 lead. 2 sodium. Ooh, 2 sodium. Looking good. And 2 chlorine. 2 chlorine. I'm not going to draw a smiley face on the board. I'll just do this. Success. And now you know how to balance chemical equations. Like I said, this is a very important skill for chemists and for Chem 1 1105 students in my class. Because did I tell you I've never broken a promise to myself? Never. And I promised to Dr. White on test 2, there'll be at least 3, maybe 4 balanced chemical equation problems, 3 point each, like this, balance the following chemical equation. All right, let's move on. Good news, it's time for something exciting. Well, hopefully this whole semester's been good. This is really exciting. And you can see I'm all fired up. This is the mole. Now, what is the mole? The mole in this class is not a furry little animal that goes on the ground and digs holes. Shucks, it's not. But anyways, it's the counting unit chemists use. And there are different ways of discussing or defining a mole. And usually a mole, just like a dozen is 12, one way of defining a mole is 6.02 times 10 to the 23rd units of anything. And you'll find out units are usually atoms or molecules. This is chemistry. But a mole of anything is Avogadro's number, and it's named after him, even though he's not the one who came up with that number. A German chemist who unfortunately I can't remember his name, who should have been credited. But Avogadro did work to help establish the theories behind to let the German chemists come up with that number. So that's why it's named in his honor. But a mole, one definition is Avogadro's number, 6.02 times 10 to the 23rd. Remember I told you you learn a lot about me personally in this class? And I said that the first, it's time to learn something about Dr. White. Coming up, end of December is my birthday. And my all-time favorite birthday gift, and there's still plenty of time to save for it, is a mole of pennies. I just want a mole of pennies. They're pennies. Or you can do it in a check or dollar bills, but equivalent to 1 mole of pennies. And if you do the math, which I did, a mole of pennies comes up to 100 million piles. Each pile has $1 billion, which means it's probably all the money that ever has been, will be, and is on this planet. It's just a mole of pennies. Pennies, come on, you can get that to me for my birthday. A mole of pennies. Mole is a large unit, and it's the chemist counting unit, and you should know the mole is the chemist counting unit. Now, in light of my change in philosophy for 1105 and general chemistry, on a test, I will give you 1 mole equals Avogadro's number. In the past, I made students memorize that. So let's look at a mole. And it turns out it's a very powerful concept. 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd things, and we'll learn things is really atoms or molecules. Now, something you don't know, first of all, can I have everybody's attention? Everybody, take a deep breath, let it out, take a deep breath, let it out. Are you all nice and relaxed? Stay that way. We're going to do stay relaxed, some math and algebra here. Stay relaxed, and I'll teach you how to do that. That's the way I always do. But we'll do some, and you'll get it. Stay relaxed. All right, a little math. If I have 2 things, one is equal to the other, A equals B, numbers, whatever, units, you name it. Therefore, I can always define or develop or write down 2 ratios. If A equals B, I know A per B is true, and I know B through A divided by A is true. Think of this as per. Think about this. If I have a dozen A's, I know two things. How many eggs in a dozen? 12. So I know 12 eggs. I can spell it right. Did I tell you I'm always the first one down in spelling bee? 12 eggs per 1 dozen. And how many eggs, how many dozen per 12 eggs? And the answer is 1. They're not equal, they're separate ratios. And therefore, if this is true, and 1 mole equals Avogadro's number of things, later on atoms and molecules, you know you have 2 ratios. Avogadro's number in terms of atoms or molecules per 1 mole, or 1 mole per Avogadro's number of, and you'll learn later on, atoms or moles. And this turns out to be an extremely, extremely powerful and useful concept in chemistry. That concept allows someone like me, when I was in industry, to write procedures, also called recipes in some, how many of each chemical to put together to make the plastic for this bottle, to make the soap that got my shirt clean, to make the fabric softener. I've done all these things that made my shirt nice and soft. And that's the concept of a mole. And because this is chemistry, we talk about a mole, and now I'll rewrite this. And this will be given to you, but you should know how to use it. One mole of an element, gold, silver, copper, whatever, equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. 1 mole of a compound, say water, or oxygen gas. And these will be given to you, but you should understand how to use them. 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd atoms of an element. 1 mole of a compound, say water, is equal to Avogadro's number of molecules of that compound. So if I said I had a mole of water in my bottle, I'd have a lot of molecules, 6.02 times 10 to the 23rd. If you don't believe me, sometime when you have nothing better to do, convert 6.02 times 10 to the 23rd in a decimal number. Be prepared to write a lot of zeros. 22 after the 2. And 21, excuse me. That's a big number. So there's a lot. Now, how do we use this in chemistry? Well, let's find out. It's practice time. And now, everybody, I'm going to be teaching you something that will be, well, has been for many decades, my good friend and my good buddy, and it will be your good friend and your good buddy, unit analysis. And let's look at the following. Sometime in the future on a piece of paper I might hand out in there, here, I asked, how many molecules of water are in 5.71 moles of water? Well, the first thing you should do is ask yourself, what unit or what am I being asked to find? And the answer is molecules of water. Next, what are you given? There's only one number I'm given, 5.71 moles of water. Now, the good thing is looking at by the way, everybody take a deep breath, relax. This is called relax a word problem. And I've had in the past students who've come to me at the end of my semester of 1105, where I used to teach 1211 years, and say, oh, I wish I'd learned what I'm going to teach you now, unit analysis and how to look at a problem before I took math, because I would have done a lot better on word problems. And the answer is you probably would have. Then I drink some of the molecules of water. Let's go on. All right, so how do you proceed? Well, there's only one factor number I have here, and that's this number. What if there was some magic ratio? No, it's chemistry, not magic, but if there was, that I could convert this to my answer. What's my answer? What units do I want my answer? Molecules of water. I'm running out of space here, but just sorry about, you can tell which is which. Now, watch closely, because this is how you use the unit analysis. You're a good buddy, you're a good friend. By the way, I'm going for the Guinness Book of World Record saying you're a good buddy, you're a good friend, unit analysis the next couple of weeks, because it will be. Whatever units you're trying to get to goes on top of the ratio. Well, I'm going to put that there. Whatever units I don't want in my answer, and I sure don't want that in my answer, I'm going to put at the bottom of the ratio. And now the question is, where do I get what's filled in there? Remember, A equals B, therefore you have two ratios, A over B and B over A. And if we look over here, ooh, 1 mole of a compound, that's water. What is it equal to? Avogadro's number. Therefore, we have the ratio B divided by A, Avogadro's number, per that. So I can put in here 6.02 times 10 to the 23rd, and this is 1. Now, before I go any further, I'm going to check my work. How do I do that? Well, you use your good buddy, your good friend, unit analysis again. And now if I just look at the units I'm multiplying, dividing, I have moles of water times molecules of water divided by moles of water. And anything divided by itself becomes the number 1 and essentially cancels out. This cancels out. What units am I left with? The ones I want, so I'm on the right track. This is important, because sometimes I see students get confused, mess it up, have that reverse, which they shouldn't, but if they even did this in their mind, they would have said, I didn't get the right units. If I had it reversed, it would be moles times moles divided by molecules. Nothing cancels out. That's not what I want. Now, let me also tell you, this is a definition. This number is an exact number, 1. Avogadro's number is a calculated number, therefore I have it to 3 significant figures, and that's what I'll always use on a test. Ask you to use. One day when I had nothing better to do, you can tell I had nothing better to do, I found a reputable website that had Avogadro's number to 20 significant figures. Why anybody would need that, I have no idea, but it's out there, but I only use 3. So if we look at this, First of all, let me get my calculator out, courtesy of Bill Gates, Microsoft. I'll come here. I'll have 5.71 times Avogadro's number. And this is what my calculator gives me. On test 2, like test number 1, it will say, please use proper significant figures for all calculated answers. So if you put that down, I'm going to take off a point. What do? Well, you look at this as a multiplication, division. 3 significant figures, 3 exact number. How many should my answer have? The answer is 3. How do you round this off to 3? Keep the 3, keep the 4, keep the 3. The 1 to round off is 7. Is that 4 or less or 5 or higher? Time's up, hopefully you pick 5 or higher. And therefore this is increase, this is drop. So the correct answer for this would be and that's what you get. Now, let me go through this again so you understand how to use your good buddy and your good friend unit analysis. I found out, what am I trying to find? My units. I look at here, what am I given? One number. I say if I have this one number I start with, what units do I want to get to? My answer. And now I use your good, I keep an count, your good buddy, your good friend. Trust me, I've learned this in high school. I'm forever grateful to Mr. Salners, who was my AP chemistry teacher in high school, that, how should I say this politely, burnt it into our DNA. That I know, and it's been my friend ever since. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes on here. Where do I get this number? From this ratio. And that's how you do unit analysis. Now, why don't you try this? First thing I would ask you to do is write down right here on your piece of paper, wherever, what are you being asked to find and what are you given? We're going to do this stepwise. What are you being asked to find and what are you given? Don't set it up yet.
What does it say after moles?
What?
What does it say after moles?
AU is gold. It's the chemical symbol for gold. I'm going into high rent district today. I'm not holding back any expenses for you people. We're talking about gold. All right, let's do this. Question is, what are you being asked to find? How many moles of gold? Well, I can put that down here. I don't know when I started using the question mark. I'd already been using it in college, or late college, I know. Anyways, I use it. You can do whatever you want to indicate this is what we're trying to find. What are you given? And this is what you're given. Now, what would you put there, and what would your units be, and what would be in the ratio? Why don't you try that? And don't worry if you don't have your calculator today, just put the numbers in. By the way, you can look over here as well. I think everybody's done. Let's do this. Now, the question is, how do you proceed? You're given only one number here. Once you've done this, you don't have to look at the per words again. And that number is 7.513 times 10 to the 26 atoms of gold. What units am I trying to get to my answer? Well, it's right here. We took the time, you took the time to figure that out. And that's moles of gold. And now you use your good buddy, your good friend, mine for many decades now, unit analysis. Whatever you're trying to get to goes on top of the ratio, units. Whatever I'm trying to get rid of goes underneath the ratio. And where do we get that? 1 mole of an element, gold, 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd. Now, before I pick up my calculator, I would recommend do the units cancels out. Notice this would be atoms of gold times moles of gold on a test. You don't have to do this on paper. I'd recommend you do it on, is that better? In your head, and then I'm dividing by atoms of gold, and anything divided by itself equals the number 1. Atoms to gold divided by atoms of gold becomes the number 1, cancels out. I'm left with this, which is my answer, so I'm on the right track. And now I'll pull out my calculator and come up here. Don't forget that. And this is what my calculator gives me. And if you put that down, I'll take off a point. Also check to make sure I put my numbers in correctly. And the answer is, I did. And if we look at this number, well, how many significant figures should it be? Well, if I come over here, this is 4 significant figures. All non-zero numbers are significant. This is 3. 0 past the decimal, or 0 between 2 numbers. Either way, that's 3. When you do a multiplication division, you get the same number of significant figures in your answer as the number that you're multiplying or dividing that has the lowest significant figures. Don't forget this is an exact number, doesn't play a role in significant figure. So I have to round that off to 3, keep the 1, keep the 2, keep the 4. Is 8 4 or less or 5 or higher? Time's up, hope we all pick 5 or higher. So I can drop that into 0 into 1, and increase the 4 to 5, and my answer would be 1.24 times 10 to the third moles of gold, which means I've got a nice little sum of gold that I just figured out. Now I gotta figure out how to spend it. No. Anyways, it's Bad Humor Wednesday, and that's how you, oh, let's do one more. Remember, the key to your analysis is the ratio, what you're trying to get to goes on top, what you're trying to get rid of goes underneath, and I shouldn't erase it. Or do you have a general question?
Yeah, for the 1.24, wouldn't you round it to 1.25?
Didn't I do that?
No, you put 1.24.
Thank you for correcting me, I
Oh,
forgot
okay.
to. Hold on, everybody, bad Dr. White.
I had another question with some good figures. So the number was 7.513. That's
4 significant.
4, but then you did 1.24 to 3 different figures.
But I should have, I wrote it down wrong, I made a mistake.
Wouldn't it be 1.248 then?
It would be 1.245. Keep the 1, keep the 2, keep the 5. 4, the 8 you round off and you increase it by
But there
1.
was 4 significant figures in the first one.
But there were 3 in the second one. 6.02. We'll do another one, you'll see. Now, why don't you try this all by yourself? See how nice I am, how you have fun all by yourself. Be quiet, Dr. White. And the question is, how many molecules of ammonia and H3 are in 8.111 moles of ammonia? Time flies when you're having fun with moles and balanced equations. right, I think everybody's done. Let's do this. And the first thing I like to do when I see a problem like this is ask myself, what am I being asked to find? And write it down. You don't have to do this. And the question is, how many molecules of ammonia? What am I given? That I have 8.111 moles of ammonia. Oh, by the way, in most books nowadays, you'll see moles spelled M-O-L. I'm the old school. I like to put the E there. And good habits Dr. White doesn't break. And now, how do we proceed? Use your good buddy, your good friend, unit analysis. And the only thing I have is this number. What answer, unit-wise, do I want to get to? This unit, molecules of ammonia. And if I can convert that in one ratio, it's time to use your good buddy, your good friend, unit analysis. Whatever units I'm trying to get to, go on top. Whatever units I'm trying to get rid of, go underneath. And where do I get these numbers to fill in here? From this. 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules. So I know 1 mole, remember the two ratios, is 6.02 times 10 to the 23rd. Now, do my units cancel out? Do I get it? Moles times molecules divided by moles. This divided by this, I erased it. A divided by A equals 1, so this cancels out. And I'm left with my right units. So now, let's see if Dr. White won't make a mistake. And my calculator gives me this number, and the question is, what do you write down? Now, how do you do this? This is an exact number. It doesn't play a role in determining significant figures. This has 4 significant figures. All non-zero numbers are significant. This has 1, 2, 3. And our answer should have the same number of significant figures as the numbers we're multiplying and dividing. It has lowest, which is 3. How do I round this off to 3? Keep an eye on me. I already made one mistake tonight. And I say, keep the 4, keep the 8, keep the 8. The round off number is 2. This is 4 or less. So I lose all this. Hold on, I better do this with 2 hands so I don't make a mistake. No. And that would be 4.88 times 10 to the 24th molecules of ammonia. And that's how you do these type of problems. And use your good buddy, your good friend, in analysis. So we've done our practice time. Let's talk about another important concept. That's called molar mass. And notice, your instructor will mostly call this molecular weight, which is abbreviated by MW. And molecular weight, which you'll see in probably next Monday, you'll have to wait till then, is quite an important number to know how to calculate. And the molecular weight is the sum of all atomic masses of all the atoms in a molecule. So, So you should know, or actually I'll also give this to you on test number 2, important information. I used to make students memorize this, but you should know how to use this. Now, have everybody's attention? If you look at the periodic table, look at hydrogen. The atomic weight or mass is the number underneath the name 1.008. It's time for a gift from Dr. White. A little gift, but it'll make your life a lot easier. On my test 2 and 3 and 4 in the final, it will say underneath your name, 1, please use proper significant figures for all calculated answers. And 2, the next thing, which is new, my gift to you is, please use all atomic weights to 3 significant figures. So let's see how this helps you out. And sometime in your future, you see something on a piece of paper, 3 points each. What is the molecular weight of? And you see water. And you say, how do I do that? Well, you know the molecular weight is the sum of all atomic weights. So now we have to do some simple addition and math. I have 2 hydrogens in water, 1 oxygen. To 3 significant figures. What's the atomic weight of hydrogen? 1.01. You round this off to 3 significant figures, 1.01. And there are 2 of them. 1 oxygen. You look over here at oxygen on this periodic table. It's 15.9, get that to oxygen, 15.999. Round that off to 3 significant figures, you get 16. This is 202, 16.0, 18.02 if you add it up. 1 times this is that, 1 times 16 is that, add it up. Now, remember addition significant figures. You have the same number of significant figures past the decimal as the number you're adding that has the fewest significant figures past the decimal. You have the same number of significant figures past the decimal as the number that has the fewest. This has 2, this has 1. What's the lower number? Times up, but we all pick 1. Therefore, past the number should have 1 significant figure, keep the 0. This is to round off, it's 4 or less. So the correct answer is 18.0. And that's how you do molecular weight. Remember, my gift to you will be 3 significant figures for all atomic weights. And I'm going to let you out a whole 5 seconds early.